Uncertainty calculations. So uncertainty at its heart is given to communicate the range of acceptable values given the precision of your glassware. We measure everything in the chem lab, and so everything that we measure will have an uncertainty range. So remember that all the values within that range are acceptable, and you are only as precise as your least precise instrument. So a couple of examples of uncertainty calculations. If it's just addition and subtraction, you simply add the uncertainties, whether you were adding or subtracting. So for example, 3.5 plus or minus 0.1 plus the value 6.25 plus or minus 0.05. So I simply add 3.5 plus 6.25, bring down the plus or minus, and then add my uncertainties, 0.1 plus 0.05. So I get my final value is 9.75 plus or minus 0.15. So this means that all the values between 9.90 and 9.6 are equally acceptable. So it's not saying that 9.75 is the gold standard and these are like, if you have to. These are all equally valued. So 9.90 is 9.75 plus the uncertainty, and 9.75 minus 0.15 is 9.60. For multiplication and division, we're aiming for the widest possible range of values. That's what our uncertainty tells us. So for multiplication alone, I would be multiplying my values 2.5 times 4.8, and that gives me 12. And then my highest possible range will be my highest possible values multiplied. So 3.0 is 2.5 plus its uncertainty, and 4.8 is 4.8. 4.9 is 4.8 plus 0.1. And that gives me 14.7. And then similarly for my lowest possible value, it would be my lowest possible numbers multiplied. So 2.0 times 4.7, that's 4.8 minus 0.1, is 9.4. So because the highest possible and lowest possible values are not equidistant from 12.0, right? So 14.7 is 2.7 away from 12.0 and 9.4 is 2.6. I can't simply report it as 12.0 plus or minus a value. So there are two options, and the preferred method in this class is to report your value, 12.0, and then give the range. 14.7 is your highest possible, and lowest possible being 9.4. And this is preferred because we use error bars in graphing, and error bars can and often are asymmetrical. So I would graph it as my value 12 with the lower bar being extended to 9.4, and the highest possible one being extended up to 14.7. Option 2 is to use the larger uncertainty. So 2.7 is the larger uncertainty, 14.7 is farther away from 12 than 9.4 is, and to report that as my value for 12.0 plus or minus 2.7. And we use the larger uncertainty because we want to better communicate the actual precision. And it's better to underestimate the precision than to overestimate. If you overestimate how precise your equipment is, you might not land on Mars, you might whiz past it. So if I'm looking at fractions, anything that's divided, again, I'm looking for the highest range, and the highest range will give me the highest possible value will be my highest possible numerator divided by my lowest possible denominator. And then likewise, my lowest possible value will be my lowest numerator divided by my highest denominator. So my highest possible numerator is 3.5 plus 0.5, or 4. And my lowest possible denominator would be 6.15 divided by minus 0.01. So 4.0 divided by 6.14 is 0.651. If I had no uncertainty, it would be 0.569. And then my lowest possible numerator, again, 3.5 minus 0.5, and 6.15 plus 6.16 will give me the lowest possible range of 0.487. So I would report it as 0.569, highest possible 0.651, lowest possible 0.552.